In this video, I'm going to explain the concept of track, and also the contents of this video consist of an introduction to track, the basics of track, the construction of track, IV characteristics of a track, and working and operations of a track, along with the modes of a track. Let us start with the introduction of track. The track is an important member of a thyristor family. The full form of track is nothing but it's a triode for alternating current. TRI stands for triode, and E stands for alternating, and C stands for current. That is triode for alternating current. In other words, it can be also be called as it's an advanced version of a diode. Now compared to SARs, SCRs are also one of the family member of a thyristor. SAR was a unidirectional device, but Triac is a bidirectional device. As we know that SAR was a unidirectional device and was having a reverse blocking characteristics that was preventing the current flow in the reverse biased condition. But according to the many applications, bidirectional control of current is required for particularly AC circuits. To achieve this SARs, two ACRs must be connected in anti-parallel to control over both positive and negative half cycles of the input. Track is a bidirectional switching device that can control the AC power efficiently and accurately. The uses of track are it can be used in motor speed controllers, in some AC circuits, pressure control systems, light dimmers, and other AC controlled equipments. In this slide, I am going to explain you the basics of track. As we know that a track is a bidirectional device that can pass the current in both forward as well as reverse bias conditions. And one more important thing about the track is it can be used as a triggering circuit in both the directions. Now the track is an abbreviation of triode, that is AC switch. TRI means that the device consisting of three terminals, tri or triode, and AC means that it can control the AC power. The main basic function of track is it is used for AC controlled device. It can be used for only AC controlled devices, and it can conduct in both the directions of an alternating current. You can see in the image where I'm going to explain you the circuit symbol of track, how two SARs are connected to each other, that I'm explaining in two thyristor analogy. And next is physical construction of track. As you can see the circuit symbol, if I'm bifurcating this particular symbol, this circuit symbol is a combination of two SARs. Let us consider this as SAR1, this as SAR2, and two terminals we are naming it as MT1 as well as MT2. And both the gate terminal of SAR are connected to form one gate terminal. It is having two terminals, that is MT1 and MT2 as an anode and cathode, and gate terminal. So basically this device is having three terminal, and which is working on a complete cycle of applied AC input voltage. Construction of track. As I said that track is a combination of two SARs. By looking into the physical construction and what we previously have studied regarding SARs, SARs are having four layers, that is either PNPN or NPNP. And according to the structure which I have discussed, one is two SARs which are back to back connected, which forms an track. So let us consider first SAR, so that is of PN type, and second SAR which is reverse connected, that we can consider it as NP type. The physical construction of these two SARs you can see in this particular figure, where the gate terminal is being connected to P of first SAR and N of second SAR, and MT1 is connected to N and P of the two SARs, and MT2 is connected to P and N of this SAR. Now let us understand, with respect to this physical construction, the 2D model of the track. In this 2D model, you can see it is having three junctions, that is J1, J2 and J3. And in this 2D construction of track, where N1, N2, N3 and N4 are the four N type of layers, and there are two P types of layers that we are representing in terms of P1 and P2. The junctions J1 are representing with respect to the layer P1 and N1. Junction J2 is with respect to N1 and P2, and junction J3 is with respect to the layer P2 and N3. When SAR T1 is forward biased, and at that particular time, if MT1 is positive and MT2 is negative, At that particular time, we can call it as SAR. T1 is in forward bias, and T2 will be in reverse bias. Due to which, as you can observe in the VI characteristics of Triac, as the voltage is increasing at certain period of time when there is a forward breakover voltage occurs. At that particular time, whatever the leakage current is there, that will be in a minimum. There is an increase in voltage, but the current is very much less. And at the breakdown, at the forward breakdown, the voltage starts reduces, and again the current increases once we apply certain gate voltage, which we can see in the VI characteristics, that is with respect to T1 of forward bias. Similarly, when a particular gate current, if it increases, if a gate current which is increasing, that it means that the forward voltage also decreases slowly, which you can observe in the figure. Like for example, IG1, you have increased the gate current. Because of increase the gate current, the forward voltage is getting reduced. And again in IG2 you have increased, again it is reduced. IG3 it is increased, again the forward voltage decreases. So with respect to this equation, like whenever Ig3 is greater than Ig2, which is greater than Ig3, we can say that the forward voltages decreases with respect to the increase in current. Similarly, when in the case when MT1 is negative and MT2 is positive, at that particular case T1 will be in reverse bias and T2 will be in forward bias. Whenever T2 is in a forward bias, at that particular time in the VA characteristics of track, you can see in the third quadrant, that is with respect to the reverse bias case. Now here the explanation is same as that of your first quadrant explanation, where you are seeing a reverse leakage current. Here also it is with respect to at certain amount of time there is a forward breakover voltage which is occurring. At that particular time, again the voltage drastically reduces once we apply a gate current towards that, and slowly the current increases later. Similarly here, if you are increasing the gate current, that time the forward voltage also decreases, which you can see in the VI characteristics diagram. Operations of track. There are four possible electrode potential combinations, or we can say that four different operating modes of a track, that is as listed below. That the terminal MT2 is positive with respect to terminal MT1, with gate polarity to be positive with respect to the terminal MT1. This is the first one. Second is MT2 terminal is positive with respect to MT1 terminal by keeping the gate polarity to the negative. Next is MT2 is negative with respect to MT1 with gate polarity negative with respect to MT1 terminal. And the last mode of operation is MT2 is negative with respect to MT1, with gate polarity positive with respect to MT1. The first mode of operation is when MT2 is positive and positive gate current. By looking into this particular diagram of Triac, you can observe that MT1 is connected to the negative terminal, MT2 terminal is connected to the positive, and gate terminal is also connected to the positive. When MT2 as well as the gate terminal, when it is connected to the positive, with respect to that, the junctions J1 and J3 will be in the forward bias and J2 will be in reverse bias. The device will only be conducted when all the junctions are in forward bias. The main condition for the device to be conducted is all the junctions should be in the forward bias. At that time only the device will be in conduction mode. When a particular gate current is applied, the gate current flows from N3 to P2 to N2, then to MT1 terminal. If the gate current flows from this direction, the electron flow will be from the opposite direction or in the negative direction. Means electron flows from N2, then P2, then N3 in the negative direction. Now once electrons flows from the negative direction, as N2 is highly doped, the number of electrons entering into the N2 layer will be injected to the P2 layer, due to which the PT layer is heated up and breakdown occurs. Because the junctions J2 was in reverse biased, due to the breakdown occurring at junction J2 because of the electrons entering into P2 with respect to N1 and P2 junction, that is J2, will be in the forward bias. And J1, J3, as we know that it is forward bias, even J2 will be in forward bias. And the current flows from MT2 to MT1 terminal, from high potential to the low potential. Second mode of operation is M22 is positive and negative gate current. By looking into the figure, MT2 is connected to the positive terminal of the power supply and negative terminal is being connected to MT1 terminal, and also the gate terminal is connected with a negative current and the positive current is applied to MT1. By looking into this figure, based on the connections, we can analyze that the junctions J1 and J2 are forward bias and junction J3 is reverse biased due to the negative gate terminal which is connected to N3. As we know that the device is going to only conduct when all the junctions are in forward bias. To convert all the junctions to the forward bias, let us apply a gate current. When a particular gate current, when it is applied, the gate current flows from empty-1 terminal, N2 terminal, P2, and then N3. When the flow of current is in this direction, the electron flow will be in opposite direction. Means electron flows from N3 to P2. As N3 is highly doped, in this case, the number of electrons entering into N3 layer will be injected to P2 layer, due to which the P2 layer is heated up and the breakdown occurs. Once the breakdown is occurred, the J3 junction will be in forward bias and the current flows from MT2 to MT1 terminal, that is from high potential to the low potential. Mode 3 is MT2 is negative and positive gate current. In this kind of mode of Triac, as looking into the figure, the MT2 terminal is connected to the negative of the power supply and there is a positive gate current which is applied towards the gate terminal, and MT1 will be in a positive to the power supply. With respect to this figure, what we can analyze is the junctions G3 is forward bias and junctions G1 and G2 are reverse bias. As we know that the device is going to conduct only when all the junctions are in forward bias. In this case, whenever a particular gate current is applied, the gate current flows from N3, P2, then N2 to MT1. Once the gate current flows from this direction, the electron flows will be in negative direction. That is from MT1 to N2, then from N2 to P2. As N2 is highly doped, the number of electron entering into N2 layer will be injected to P2, due to which the P2 layer is heated up and the breakdown is occurred. Okay, and N4 is also now, because of this particular breakdown of P2 layer, the junction J2, which was in reverse bias, will be converted to the forward bias with respect to P2N1. Similarly, the junction J1 was also in the reverse biased. To convert the junction J1 to forward bias, now N4 is having a majority carriers. So when a negative voltage is applied through MT2, at that particular times, whatever the number of electrons which are entering from N4 to P1, that makes it to be a breakdown, due to which P1 and N4 or P1 will be heated up and the breakdown occurs, and P1 and N1 will be forward biased and the current flows from MT1 to MT2, that is from the high potential to the low potential. The last mode of operation is when MT2 is negative and negative gate current is applied. In this case, as looking into the Triac diagram, what we can observe is MT2 terminal is being connected to the negative of power supply and the positive terminal of the power supply has been connected to MT1, but the current positive terminal of a current is given to MT1 and negative terminal is given to the gate terminal. In this mode, the junctions J2 will be in forward bias and junctions J1 and J3 will be in reverse biased. As we know that the device is going to be conducted when all the junctions are in forward bias. Now, when gate current is applied, the gate current flows from MT1 to N2 terminal, then P2, then N3. And the flow of electron will be in the negative direction, that is from N3 to P2. As N3 is highly doped, the number of electrons entering through the N3 layer will be injected to the P2, due to which the minority carriers in P2 layer is repelled into N2, due to which the breakdown occurs. Similarly, N4 is having a majority carriers. So when negative voltage is applied through MT2, then the breakdown occurs because the carriers are injected towards the P1 terminals. Now the current in this mode of operation flows from MT1 to MT2 terminal as shown in the figure. This diagram represents the VI characteristics of a track with respect to the operations of all the four modes, where you can see two modes are in the first quadrant and two modes are in the third quadrant. This entire figure is representing the VI characteristics of the track.